Good morning, students. So, in the last class, we have completed Chapter 8, and I hope all of you understood all the sums those are given in the exercises 8.1 and 8.2. In case any doubt regarding that chapter, please ask me. Okay? You can ask me anytime if you have any doubt. Okay? So today I'm going to give the conception of chapter 9. As I told you in the last class that chapter 9 is fully removed by the CBHC because in this year they have removed 30% syllabus. That is why they have removed chapter 9 also from your course. But I thought that you should get the concept of chapter 9 because we cannot skip the concept. Sometimes it will be needed. Okay, chapter 9, it is areas of parallelograms and triangles. So all if you know what is parallelogram, what is parallelogram and triangle. So here area of parallelogram, what is area of parallelogram? Half into b into h means base into, area of parallelogram is base into height, and area of triangle, area of a triangle is what? Half into b into h. This is general conception of area of parallelogram and area of triangle. Area of parallelogram is base into height and area of triangle is. But here we will compare the figures. Okay, see, this is a figure. The name of this figure is T, and you can see there are two parts of this figure. This name of this figure is P and the name of this figure is Q. So we can find out the total area, means area of figure T. We can find out area of P plus area of Q. Okay, this is not a parallelogram or triangle, this is just simple figure. Okay, now note 1, you may denote the area of figure A as area of A. Suppose you are having a figure A, suppose any figure A, that area of figure A, so you can write shortcut ARA means, air bracket A means area of A, area of figure A. Okay, case note 2, if A and B are two congruent figure, then their areas are equal. It means area of figure A is equal to area of figure B. Means congruent figure, if you get congruent figures, then their areas are equal. Okay, this is general conception of this chapter. Now what is the main thing of this chapter? This is figures on the same base and between the same parallels. Same base and between the same parallel. Which are the figures are called same base and between the same parallel? Let's see the example. Suppose ABCD is a trapezium here, and you can see this is a triangle DPC. See, this DC is the base for this trapezium, and DC is also the base for this triangle DPC. And also you can see DC and AB are the parallel lines. Parallel lines or not. And you can see clearly that this triangle DPC and triangle ABCD are between the same parallel lines, AB and DC. Like these figures are called same base and between the same parallels. Means triangle DPC and trapezium ABCD are on the same base what? DC, and between the same parallel lines AB and DC. I hope all of you understood now. You can recognize now easily this one, same base, and this one. But you can see this figure. See, here you can see the PQR and ABCD. Suppose ABCD is a parallelogram and PQR is a triangle. You can see this DC and AB are the parallel lines, means this triangle and this parallelogram are between the same parallel lines, but they do not have same base. See, DC is base for this triangle and DC is also base for this trapezium. But in this case you can see this PQ is base for this triangle, but DC is base for the parallelogram. That means the bases are different. Hence they do not have same base, but they are not between the same, but they are between the same parallel line. So this is not means you can see this figure maintaining the one criteria and not means one condition, but it is not maintaining the second condition, same base. So those figure you can see this figure like that, same base also between the same parallel also, but this is they have not same base, but they are between the same parallel. So I hope all of you recognize now like this figure. Okay, next 9.1. Okay, theorem 9.1. Parallelogram on the same base and between the same parallel are equal in area. You can see here ABCD and EFCD, ABCD and EFCD, they are two parallelograms and they have same base. What? Same base DC and parallel lines what? AB and DC. According to this theorem, if you can find like this figure, two parallelograms same base and between the same parallel lines, then you can say that their areas are equal. It means area of ABCD is equal to area of EFCD. Okay, next theorem 9.2. Two triangles on the same base or equal bases and between the same parallels are equal in area. Similar case, see in this case you can see two parallelograms are on the same base and between the same parallel their areas are equal. Similarly, in this case you can see two triangles same base are on the same base and between the same parallel. Suppose you can see this triangle ABC and PBC. BC is the same base and this AP and BC are parallel, means between the same parallel lines AP and BC and same base is BC. Then in this case also you can say that area of ABC is equal to area of PBC. Means if two triangles are on the same base and between the same parallel, their areas are equal. Clear? Then theorem 9.3. Two triangles having the same base or equal bases and equal areas lie between the same parallel. This is little different. See, in this case we understood that from theorem 9.2, if the two triangles have same base, are on the same base and between the same parallel, their areas are equal. And according to theorem 9.3, suppose you are having that areas of this triangle are equal, means area of ABC is equal to area of PBC. Also they have same base BC. It is not given that this AP is parallel to BC, but it is given that area of ABC is equal to area of PBC and they have same base. So you can say that they are lie between the same parallel lines. Okay, it's like converse. They lie between the same parallel. If area is equal and they have same base, then they lie between the same parallel. Therefore, AP parallel to BC you can say that. Clear? Okay. Case 1. If a triangle and a parallelogram are on the same base and between the same parallel, then prove that the area of the triangle is equal to the half the area of the parallelogram. This is an example. Okay, you will get this one as an example. Please try to understand this one. It is given in your book. The proof already given in your textbook. So I will give you the conception. See, just now we have understood that if two parallelograms are on the same base and between the same parallel, their areas are equal. Also, if two triangles are on the same base and between the same parallel line, their areas are equal. But if one parallelogram and one triangle are on the same base and between the same parallel, suppose here triangle APB and parallelogram ABCD, you can see AB is the same base and between the same parallel AB and CD. What we will say in this case? In this case, means one is triangle and another is parallelogram. They are on the same parallel. They are on the same base and between the same parallel. So in this case, you can say that the area of this triangle is equal to half of the area of ABCD. Clear? Okay. Case 2. A median of a triangle divided into two triangles of equal areas. So what is median? First of all, you have to know. If AD is a median of BC, okay, so of triangle ABC and AD, you can see here AD is the median of triangle ABC, then a median divides the sides into two equal parts, means AD, then it is a median, then you can say that BD is equal to CD. This is a concept of median. BD is equal to CD. Now, according to this theorem, if you draw a median like this, suppose this one, or you can draw from this vertices, you can draw from this, that is also, suppose this is AD and this Okay, then according to this theorem, a median divides the triangle into two triangles of equal areas. Means after doing this median, you can see there are two triangles, and this triangle and area of this triangle is equal to this triangle. Means area of ABD is equal to area of ACD. Clear? So these are the conception those are given in chapter 9. I repeat, first we got if two parallelograms are on the same base and between the same parallel their areas are equal. If two triangles are on the same base and between the same parallel their areas are also equal. If one triangle another parallelogram and one parallelogram are on the same base and between the same parallel, the area of the triangle is equal to half the area of the parallelogram. And next we learned that a median divides a triangle into two triangles of equal areas. Yes? I hope all of you understood this. Okay? So, to recognize the figures like those have same base and between the same parallel, I want to give you some homeworks. Okay, only this thing you can do. In the next class we can study a new chapter. So suppose for this I want to give homework exercise 9.1. Only 9.1. In exercise 9.1 question number 1 there are some figures. You need to say that those figures have same base and between the same parallel, and also you need to write the same base and the parallel lines. Okay, read the question and you'll understand. This 9.1. Okay, other exercise no need. Or regarding this conception what I have told you today, if you have any doubt please get back to me in the evening and submit this homework. Okay, thank you.